My name is Kainton the Tech Pro, and today I'm going to explain to you in very simple terms the concept of dimensionality reduction. Before I continue, I'd like to remind you, as I used to do, to subscribe to my channel. And this way you kind of encourage me to continue making these lessons, and also you get notified when I make new lessons. And also feel free to leave me a comment in the comment box below this video. So just click on the subscribe button below this video right now to subscribe. Dimensionality reduction simply means a way to reduce a data set from a high dimensional data to a lower dimensional data. So what it means is that you have data in high dimension. Meanwhile, what is a high dimensional data? Let's start with two-dimensional data. So a two-dimensional data may be something like this: x, let's call it x1 and x2, and you have values x, I, xj, yi, yj. So this is two-dimensional data, and it's very clear. You can always plot it in this way. You have two-dimensional axis x2, x1, and you can plot x1, y1, you plot here, x2, xy2, you plot here, and so on and so forth, and you're able to then fit a line through the data, right? So this is very easy, and you're able to see that x is increasing alongside y, or xi is increasing alongside j. Let's now try 3 dimensions. So in this case, I'm going to take another color pen. So we have 3D. In this case, we have x, we have y, we have z. And again, you have sets of data. Let's say x1, x2, x3. And here you have y1, y2, y3. And here you have z1, z2, z3. Again, we can also try to plot this in 3 dimensions. For instance, you can have something like this. It's 2 dimensions, then we add a 3rd dimension, let's say coming out this way. So in this case, we have x, we have y, we have z. So you may be able to plot it and maybe visualize it in 3-dimensional space. So let's say something like this. This is a 2-dimensional space, then you can then project it into the 3rd dimension in this way. Okay, so you now have something like this. You're able to also visualize your data. So these are the data points. So it's also fine, but if we now have 4 dimensions, that becomes a problem. We will not be able to visualize data in 4 dimensions. What of 5 dimensions? What of 6 dimensions? What of 7 dimensions? 8, 9, 10, 11, 20, 100. It becomes unmanageable. It becomes unmanageable. So let's illustrate it using student subject. Let's say the student takes 10 subjects, and we want to reduce the dimension of these 10 subjects to only 2. So let's start with, we have subject 1, English, 2, maths, 3, physics, 4, we have, I want you to pay attention how we are going to reduce 10 subjects to explain 10 subjects in only 2 dimensions. We have chemistry, we have 5, we have literature, 6, we have history, 7, we have economics, 8, we have business studies, 9, we have, let's say, biology, and 10, we have, let's say finance. Yeah. All right, so we want to look for 2 dimensions only that will define or explain this data set. Let's call those 2 dimensions F1 and F2. And now, if we consider it intuitively, we can categorize these two items into, let's say F1 is, let's say, quantitative aptitude, and F2 is verbal aptitude. So what we are saying in effect is that these 10 subjects can actually be represented with F1, F2, which is either quantitative or verbal aptitude. So what it means is that, for instance, we can now say English is related, let's say English will now be, let's say 20% verbal, 20%, 10% quantitative, and 90% aptitude. So in this case, we can say 10Q plus, sorry, it should be 10. So maybe I'm going to represent it in this place. So English is equal to 10% verbal aptitude plus 90% quantitative aptitude. So this is what the equation for English will look like. Maths will be equal to English should be, it's likely to be 90% verbal aptitude plus 10% quantitative aptitude. Maths will now be, let's say, 5% verbal aptitude plus 95% quantitative aptitude, and so on and so forth. So basically, you'll be choosing all these subjects and assigning them what is called the loadings. So all these coefficients I'm writing, they are called the loadings. So for each subject, it has a corresponding loading for each of the factors you've identified. So in this case, you can actually form an equation that relates all these subjects to these factors. So in this case, we've succeeded in reducing 10 dimensions to only 2. And these 2 factors here, they are called principal components. That is in the case of PCA, although PCA is not the only dimensionality reduction techniques available out there. So if you look at this place, you have that dimensionality reduction can actually be done in either of 2 ways. It can either be feature extraction or feature selection. So in case of feature selection, we are finding a subset of the original data set. So we're actually finding a subset of original data set. But in case of feature extraction, we are transforming the original data set into a new set of features like what we've just done here. So take some time to read in my website, be able to explain it. So the idea of these questions is for you to be able to, in a quiz, explain these concepts in a very clear way. Not necessarily how to derive all the formulas, all the mathematical models involved, but to be able to explain the concept to a panel, because that is what you need to be able to do if you want to go ahead in machine learning. So I'm going to actually stop here. I'd like to thank you for viewing. I'd like to encourage you to continue learning, because machine learning is actually the way forward. That is actually what you need to learn. And if you have any challenge, you can easily leave a comment for me in the comment box below, and I'll personally reply to your comment and give you the needed support.